Alright, Janet is standing at the top of a ramp 8 feet above the ground. Her sister Regina is playing hopscotch below. Regina, whose eye level is about 4 feet off the ground, is standing at the base of the ramp, which has a horizontal distance of 6 feet. Regina looks up at her sister's feet, forming an angle of length that has a measure of blank degrees. What type of angle correctly fills in the blank labeled A? What is the measure of the angle rounded to the nearest degree at which Regina is observing her sister? Choose two answers to this problem, one for question A and one for question B. Okay, so Janet is standing at the top of this ramp, and it is 8 feet above the ground. We know that Regina is playing hopscotch, and her eye is 4 feet above the ground. That wasn't very accurate. That's okay. So that's 4 feet. So, it has a horizontal distance of 6 feet. So we know that this ramp has a horizontal distance of 6 feet. So we're going to fill in a little bit of missing information. I know this is not to scale, and that's okay. If Regina is eye level at 4 feet, and this horizontal line, that means that there is a remaining vertical distance of 4 feet for the ramp. Because 4 feet plus 4 feet equals that total height off the ground, which is 8 feet. So now it wants us to find the angle. So here's the question: is it an angle of elevation or an angle of depression? So again, remember in the last question, depression was looking down and elevation is looking up from the horizontal line. So we have this horizontal line, and Regina would look up. It says Regina looks up. There's the key word for elevation. Elevation means you're looking up, just like when you go up a mountain, you're changing elevation because you're getting higher. So that is elevation. You're looking up a mountain. A mountain has a higher elevation than we do. So it wants us to find out what this angle is. So we are going to, so for A it's elevation, and now we're going to again label this triangle according to the angle that we want to find. So we want to find this angle of elevation. So the side length that is opposite it is the opposite side length. The side length that is opposite the hypotenuse, the 90-degree angle, is the hypotenuse. And the side length that is attached to the angle and is not the hypotenuse is the adjacent side length. So again, when you go through your trig functions, the mnemonic device that I use is SOHCAHTOA. The S in SO is for sine of an angle. The O in SO is for opposite over hypotenuse. Ka, the C is for cosine. The A is for adjacent over hypotenuse. And TOA, the T is for tangent of an angle, is equal to the OA is opposite over adjacent side length. So when we look at this, we are given 4 feet and 6 feet, which is the opposite side length and the adjacent side length. So I'm going to be looking through this for one of these ratios that has a relationship between the opposite and the adjacent side length. This one's opposite but not adjacent. This one's hypotenuse, so I'm not using this. This one's adjacent and not opposite, though. It's hypotenuse, so I'm not using this one. Tangent is opposite over adjacent. So that's the ratio that I'm going to be using. So now, we have tangent of our angle, which we don't know, so we have tangent of our angle is equal to the opposite side length, which is 4 feet, divided by divided by 6 feet. I did leave a blank there just so I can write. So now we want to solve for theta. And it has this tangent being applied to our angle. And so we are going to do the same thing we do with, like, if we were like solving x divided by 4. The opposite of division is the inverse operation, which is multiplication. So that's why we multiply by 4, is because it reduces it down to a 1. So we're going to use the inverse operation here for tangent. And it's a real kicker. It's called tangent inverse. So we applied the tangent inverse to both sides. Tangent inverse to both sides. So tangent inverse of tangent of our angle, they undo each other. So we are left with just our angle is equal to tangent inverse of 4/6. So now we can jump over to our symbol lab, and we have tangent inverse. Tangent inverse, I do want that one. Not of 1 though, we want it of 4 divided by 6. So in degrees, it's 33.69 degrees. And it says rounded to the nearest degree, so 33.6 is closer to 34 degrees than it is to 33 degrees. So we're going to be rounding this to 34 degrees. So now some of you, when you're solving for an angle, you're always going to be using inverse trig functions. So you could remember or write this in your notes. When you're solving for an angle, that you have your choice. You still have your choices. The angle could either be sine inverse of, again, remember that sine was, okay, that doesn't look like it. Okay, there's sine is opposite over hypotenuse, side length, or the angle could be cosine inverse of the adjacent divided by the hypotenuse, or the angle could be the tangent inverse of the opposite over the adjacent. So now we could go through this and say, okay, well, I'm looking for my angle. I'm given the opposite and the adjacent information. So which of these has that ratio, the opposite and adjacent in it? This is opposite and hypotenuse, doesn't meet it. This is adjacent and hypotenuse, doesn't have both. This is opposite and adjacent, it has both. So then you could just say, well, my angle is going to equal tangent inverse of 4 feet over 6. And then that saves you just the step that I had shown you. So if you have this down, it could potentially save you a step.